Okay, so my project is on the correlation of trihalomethanes with head and neck cancer in the Tampa Bay area. So these right here are all of the trihalomethanes. So each one of these is actually going to be have different levels of effectivity on the human body. And keep that in mind because there's actually no standards for each individual trihalomethane. It's only total trihalomethanes that have standards on them. So there's 3 different groups that have standards for trihalomethanes. There's the Environmental Protection Agency, which is the EPA, and it has 80 parts per billion. That's what the United States goes off of. And the World Health Organization, which has 10. And the EWG, or the Environmental Working Group, which has 0.15. So trihalomethanes are known to be carcinogenic, meaning that they can cause cancer, and that they're byproducts that are formed from the cleaning process of drinking water. So in the Tampa Bay area, we use chloramine, not chlorine. And around the different parts of the country, you're going to see a difference between chloramine and chlorine. But in order to test these levels on the parts per billion level, we use headspace GCMS, which we did through optimizing the concentrations down to flow rate, GC oven temperature, vial incubation, speed of injection, all types of different parameters that we optimized in order to get it all the way down to readable levels of parts per billion. And we did this based off of what the America's standard is 80 parts per billion.
I have a quick question. Can I interrupt you? Am I allowed to ask questions in between?
Yes, go for it.
So with the 3 different standards for the parts per billion, did you look into why they're so drastic or why they're so different? Because 80 versus 10 versus 15 was, is that 0.15?
So I did. The Environmental Working Group is at 0.15 because they're basing the prevalence off of 1 person getting cancer from trihalomethane consumption out of 1 million. And that's their calculations for why it's at 0.15. The World Health Organization actually doesn't say why it's 10 parts per billion. And the EPA hasn't actually been updated since 2001. And prior to 2001, it was actually at 100 parts per billion, which was, even then, it was 10 times the World Health Organization standards. Isn't that interesting?
Thanks. Yeah.
Yeah.
I mean, because it's interesting to see such a drastic difference in their in their numbers.
Yeah, it's kind of sad, but yeah. But that being said, water disinfection is completely necessary for the safety of the individuals who are drinking it, which is everybody. If you don't have clean water, it creates a slew of different problems. But if you over disinfect it, like you add too much chloramine, the chloramine is going to react with organic substances and create byproducts, which are going to create trihalomethanes. And too much trihalomethanes can correlate to cancer. So this is the map that we've created. What you see in red is going to be the free chlorine levels by zip code. So free chlorine levels actually pretty much equate to trihalomethane levels, and we did this by measuring them on the colorimeter. And what you see in purple is the cancer levels. So the darker the colors, the more intense the levels are. So for the chlorine levels, the dark red is the highest chlorine levels. And for the cancer levels, the dark purple is the highest cancer levels. And we got the cancer levels actually as a census tract through government affiliated websites. And for the free chlorine levels, we actually went out and we tested them, and that's where we got that information from. I labeled them as zip codes so it's a little bit easier to understand, and I separated out the maps so that you can see each individual map. But as you can see here, like the really—
Did you generate the maps yourself? Sorry.
Huh?
Did you generate the maps yourself, like all of them?
I did.
Nice.
Thanks. But the dark, if you can kind of see the dark red also has some really dark purples, which correlation does not equal causation. I know we all know that, but it is a pretty scary correlation, especially in the thinking concept-wise that while these free chlorine levels are going to be high trihalomethane levels, which means that I could potentially have cancer, like get cancer.
Yeah.
And I also wanted to put the wastewater facilities on here because I wanted to see if there was a distance between, like if there's a bigger distance between the wastewater facilities and the high free chlorine levels, if you could see if there's a big difference. Because we know that based off of how far you are from the wastewater facilities or the water treatment plants, you're going to have higher chlorine levels because more organic materials, more rust is going to accumulate on these pipelines, and then that's going to cause the disinfectant, like the chloramine or the chlorine, to interact with these organic substances and cause more trihalomethanes. So in conclusion, disinfectant is very important, but it needs to be balanced. Not enough disinfectant leads to unclean water. Too much disinfectant leads to unclean water. And as you could see in the map here, big dark colors correlate with one another. So cancer versus free chlorine levels. And we're hoping that we can use this and keep going, use these results to keep our project going.
Nice, nice.
Any questions, or you got it?
You did it very well.
Thank you.
I mean, I feel like also preparing this multiple times